So here electric dipole means there are two charges which are in equal magnitude but opposite charges. They are separated by some distance. Okay. So here we are placing one charge minus q, and this is a plus q, and they are separated by some fixed distance, that is the 2a. Okay. So here we have to get the electric field due to this dipole. Okay. So here the net charge is 0. Okay, net charge is 0. Okay, that is plus q minus q gives the 0 because they are in equal in magnitude. So that means plus q and the minus q is equals to 0. Okay, so okay, but both are in opposite sign. Okay, so here when we are considering the different points, here if I am placing the point here. Okay, so I want to get the electric field due to this dipole. So that means it is at the line. Okay, it is along the axis of those dipole. So this is the axial line. Okay, so here I want to get the electric field due to dipole. So I want to get the electric field here. So that's why at the point P I want to get electric field here. I am placing one test charge here. Okay, so if I am placing the test charge here, so this is a positive charge and this is a positive. So positive repulsive. So the electric field direction is in this direction. The electric field direction is in this direction. Okay. So here this is a negative charge and this is a positive charge. Here to here I want to get the effect. So that's why this is a negative and this is a positive. So both are attract. So that's why the electric field direction is like this. Okay. So here I am getting the electric field due to positive charge. This is electric field due to negative charge. So by adding those two ones, here I am getting the resultant electric field. Okay, so that means here even the charge is 0, we are not getting electric field is equals to 0. If I am placing the point here, so this is the equatorial point. Okay, so from here to here, this is at the same distance. Here to here, this is at the same distance. The distance is same, but the effect due to positive charge at this point is different. The effect due to negative charge, the point is different. The electric field is different. By adding the electric field due to those two charges, here I am getting the resultant electric field. So we have to find the electric field at the axial line at the equatorial point. Okay. So now first the electric field intensity. First case is electric field intensity on axial line. An axial line of electric dipole. An axial line of electric dipole. Okay, so now first here I am placing the minus q charge, here I am placing the plus q charge. The separated distance is 2a. This is the center. Always we have to take the distance that is from the center only. Okay, so here I am placing I want to get the electric field at this point. This is the axis of the dipole. So along the axial line I want to get the electric field. Okay, so now this is my point P. Here I want to get the electric field. This is okay. So now see here I am placing the one test charge. One test charge means here plus 1 means okay. So that is q into 1 q minus q into 1 q. Okay. So there is no change in the magnitude in the charges. That is, so that's why here I am placing the test charge means there is no change in the value. Okay. So here I am placing one test charge. So now this is the center, this is the origin. Okay, so we have to take the distance always from the center of the dipole. Okay, so from here to this center to the our point, this is our point, no? So center to the our point we have to take the distance as r. Okay, now here I want to get the electric field. Okay, so now first, so the electric field due to positive charge at this point. Okay, so this is positive, this is positive. Those two are repulsive. Repulsive means the electric field is always away from the charge. Okay, so here this is a point, this is a positive charge. So here the electric field is always, this is the away from the positive charge. The electric field direction is from positive to negative, no? So this is the positive electric field direction, and it is away from the discharge. The electric field direction is always away from the discharge. So this is electric field due to positive charge. Now see here, I want to get the electric field due to this charge. Okay, so here this is the negative charge and this is the positive charge. So those two attracts each other. So that's why the electric field direction is in this direction. So this is the electric field direction. So this is electric field due to minus Q. Okay, now see here, the distance between positive charge to this point, I want to get the distance. This is the positive charge, no? So from the positive charge to this point P, here I want to get the distance. Okay, so see here, this is the A and this is also A. Okay, so here to here A and here to here R. So this distance is how much? R plus A. Sorry, R this total distance is R, this distance is A. So here this distance is R minus A. R minus A. Okay, so now see here, I want to get the distance from minus Q to and this point P. This is the distance. Okay, so now here to center to the point P is, so from here to here this is R. But here to here we are having the A. So this is A and this is R. So the total distance is what? R plus A. Okay. Now here we have to write the derivation. So for the derivation part, see here, we have to consider electric dipole. That is minus Q and the plus Q are separated by distance, that is 2A. Okay, and we have to calculate electric field at point P, where the unit positive test charge is placed, that is situated at that point. Okay, so here, and the distance from center to point P is what? That is OP is equals to R. This is the O and this is the point P, R. Okay, now here I want to get the electric field at that point P. Okay, so now here E plus Q. Okay, see here, this is the E plus Q, no? E plus Q is what? Electric field due to what? Which charge? Positive charge. Okay, E minus Q is what? Electric field due to negative charge. Okay, now I want to get the resultant electric field. Okay, so that is E resultant. E resultant is equals to, see here, ఇక్కడ చూడండి, so this is the electric field due to positive charge, this is the electric field due to negative charge. Okay, so here the magnitude of the electric field is, see here. Okay, so before the E resultant we have to write the individual electric fields. Okay, so electric field due to plus charge and electric field due to minus charge. So that is E field due to positive charge is equals to, according to Coulomb's law, what? Here 1 by 4 pi epsilon naught, the charge is what? Q. Okay, and here 1 by R square, no? So R square means for the positive charge, this is a positive charge. Okay, so the distance is how much? Here to here the distance is how much? R minus A. Okay, so here R minus A whole square. Okay, now the electric field due to negative charge is what? 1 by 4 pi epsilon naught Q by, and R square, no? So that means here negative charge. and at this point we are calculating the electric field. So that's why the total distance is how much? R plus A. Okay, so that is R plus A whole square. Okay, so here for the minus Q charge we have to take the minus, okay, or else here we are getting the resultant, here we are getting the resultant electric field. No, see here, this is the electric field due to positive charge and this is the electric field due to negative charge. Okay, now so here from here to here the electric field magnitude is greater one, so here to here the electric field magnitude is lesser. Okay, so that's why the magnitude of the electric field due to positive charge is greater than the magnitude of the electric field which is due to the negative charge. Why? Because see here, in the magnitude case, in the denominator this is the greater value. Okay, so in the denominator this is the greater value means here the electric field due to negative charge is less value. Okay, so in the denominator this is the lesser value, so that means it gives the greater value. So that means the magnitude of the positive charge is greater than the magnitude of the negative charge. So now here we have to get the E resultant. E resultant at that point is equals to, the greater value is what? E plus Q, and lesser value is what? The electric field due to negative charge. Okay, so that's why here electric field, the final electric field, resultant electric field at that point P is equals to what? Electric field due to positive charge minus electric field due to negative charge. So that is 1 by 4 pi epsilon naught Q by R minus A whole square minus 1 by 4 pi epsilon naught what? Q by R plus A whole square. Okay, or else here we are taking the negative charge, no? So just place the negative here, no problem. Okay, so this is a 1 by 4 pi epsilon naught. So Q same, the magnitude of the Q is same. So that is 1 by R minus A whole square minus 1 by R plus A whole square. So that is Q by 4 pi epsilon naught. So R plus A whole square cross multiplication. So minus R minus A whole square, that is by R minus A whole square and the R plus A whole square. Okay, now see here. Okay, so here this is the A plus B and the A minus B, that is Q by 4 pi epsilon naught. So by this is A plus B and the A minus B means that is R square minus A square minus B square whole square. Okay, so and see here, this is A plus B whole square and the A minus B whole square. So A square plus B square plus 2AB and minus A square plus B square. So minus 2AB, minus into minus plus, so plus 2AB. So it will be cancelled out and here we are getting what? So that is Q by 4 pi epsilon naught and here we are having that is 4AR by R square minus A square whole square. Okay, so here see here, this is the point R. When compared to this distance, that is the point distance from the charges, then the distance between those two charges will be very less. If you are taking the point here, then R will be greater than if we are taking the point here. Okay, so that means compares to the R, R means what? The distance between the center to the point P. Okay, so compares to the R, the distance between those two charges will be very less. So that's why here R will be taken as R will be greater than the A. Okay, so here we are taking the condition that R is very much greater than the A. So then we have to neglect A. Okay, so that's why here R square minus A square whole square will be written as R square. Okay, so that's why Q by 4 pi epsilon naught, sorry, here R square whole square, no? So this is R power 4. So that is 4AR by R power 4. So r, 1r will be cancelled out. Here we are taking the value, so that is equals to q by 4 pi epsilon naught, and here 4a by what, r cube. Okay, so it can be written as so what, 2q into a into what, 2 by 4 pi epsilon naught r cube. Okay, so that is equals to, already we know that dipole moment is equals to what, p is equals to 2q into a. This is the dipole moment. Okay, so here it can be written as 2p by 4 pi epsilon naught r cube. Okay, so that means here electric field due to dipole at axial point. At axial point is what? E resultant is equals to what? 2p by 4 pi epsilon naught r cube. This is the electric field magnitude at axial point of the dipole. Okay, so now here this is the magnitude only. Now I want to get the direction. Okay, so already here, so the electric field magnitude is what? 2p by 4 pi epsilon naught r cube. This is the magnitude. Now I want to get the direction. So see here, the magnitude of the electric field due to positive charge is greater than the magnitude of the electric field due to negative charge. So that's why here the magnitude of the electric field of the positive charge is greater, means here the resultant should be in this direction only. The resultant should be in this direction. Okay, so this is the E resultant direction. Okay, so here the E resultant direction is in this direction. So that means for the direction, this is a charge and this is the charge. So here we are taken one point. So this is the electric field direction. So that means this is the electric field direction. Okay, so dipole moment direction is what? Negative to positive, always negative to positive. So this is the dipole moment direction. So by comparing those two, the electric field direction is always in the direction of the dipole moment. Electric field direction is along the direction of dipole moment P. Dipole moment P. So this is the electric field direction. So this is the magnitude of the electric field. Okay, so now this is about the magnitude and this is the direction. Okay, now here now we have to know when the point is placed at the equatorial point, and we have to get the electric field. Okay, now here I am considering the electric field due to electric field at a equatorial point, due to dipole. Okay, now see here, this is a minus q charge, this is a plus q charge, and those are separated by some distance. This is known to be a dipole. Now here I am placing this is my point. Okay, that is the equatorial point. So that means it is here we are taking the center 0. Now we have to take the distance always from the center. Okay, so this is the center now. So this is my point P, and here I am placing the one test charge plus 1. Okay, so here I want to find the electric field. So here to here my distance is r. Okay, always we have to take the distance that is from the center. So that's why from the center the distance is r. Okay, now this is a negative charge and this is a positive charge. Here I want to find the electric field now. Okay, so as here I am taking the test charge as the positive one, as this is a negative one, then the electric field direction is in this direction. That means it will attract in the negative direction. Okay, now here this is a positive charge, as this is a positive charge, so it will be repelled, so that means the electric field direction is away from the discharge. Okay, now this is the electric field due to positive charge and this is the electric field due to negative charge. I want to get the resultant one. Okay, so in the vector already we know that in the vector form, okay, so when those two are like this, we are getting the resultant like this. Okay, so or else let us consider this is a parallel line, that is for the dipole axis, and this is a perpendicular line for the dipole axis. Okay, now see here, as this is the electric field due to this positive charge, it will be resolved into two components, that is along the line of dipole and perpendicular to the line of dipole. Okay, so this is a perpendicular to the line of dipole and this is the along the, that is line of the dipole. Okay, so this is the perpendicular line. Now as it is a electric field due to this negative charge, okay, so here this also resolved into two components, one is perpendicular to the dipole and parallel to the dipole. Okay, so this is the parallel to the dipole and this is the perpendicular to the dipole. Okay, so that means here this is the point. Okay, this is the negative charge and this is the positive charge. So here this is electric field due to positive charge and this is electric field due to negative charge. Okay, so this is resolved as here this component is resolved as in this direction and in this direction, and this component also resolved as in this direction and in this direction. Okay, see here as this is a equatorial one, so here we are taking the angle theta. If this is the angle theta and here also we are getting the angle theta. Okay, so as these are the if this is a theta and here we are the already we know that this alternate angle also theta. Okay, and okay, so this alternate angle also theta and here also as we are getting the angle theta. Okay, so this is a corresponding angle theta and the alternate angle also theta. So that means here we are getting the theta and here also we are getting the theta. Okay, so already we know that always we have to take the cos theta, that is along the adjacent line. So that's why here is the theta, means this will become cos theta. So this is the E plus cos theta and this is E minus cos theta. Okay, and this is what? This is the opposite one, no? So that is, this is E plus sin theta and this is opposite one, no? So that is E minus sin theta. Okay, so see here this is the E plus sin theta and this is the E minus sin theta, but both are having the same magnitude. Why here I am taking the magnitude is same? Because here this is a minus q which is at the center, from the center this is r. So see here this is a minus q and this is a plus q. So this is a center. Okay, so here I want to get the electric field. So this is a r. Okay, now here to here minus q to plus q, the distance is what? Here under root r square plus a square. Here to here the distance is what? Under root r square plus a square. Okay, so that means when we are taking the electric field at these points here, when we are taking the electric field, so due to positive charge the electric field is in this direction, due to negative charge the electric field direction is in this direction. So when we are taking the electric field, so that is equals to 1 by 4 pi epsilon naught q by r square kada. So here r square means the distance from the minus q to at this point is same, that is under root r square plus a square. No, so under root means r square plus a square, under root r square a square whole square, square root cancel. So here we are getting the electric field due to positive charge is what? 1 by 4 pi epsilon naught q by r square plus a square. Okay. Now, so here electric field due to negative charge is what? 1 by 4 pi epsilon naught q by r square means same distance. So that is under root r square plus a square whole square. So square root cancel. So that is 1 by 4 pi epsilon naught q by r square plus a square. Now, by comparing both the magnitude, so this is electric field due to positive charge and this is electric field due to negative charge. So here the magnitude of the electric field due to negative charge must be is equals to magnitude of the electric field which is due to positive charge. So as the magnitudes are equal, then here as the magnitudes are equal, so this magnitude and this magnitude equal, but both are in opposite direction. Both are in, this will be in this direction and this is in this direction. So that means both will be cancelled. Okay. So here we are getting the resultant electric field in this direction. So then E resultant will be what? E resultant is equals to what? The electric field which is due to positive charge. So the component is what? Cos theta. And electric field which is due to negative charge, the component is what? Cos theta. But both are having the same magnitudes. So that's why here we have to consider just E. Okay. So that's why E cos theta, 2E cos theta. So E resultant is equals to 2E cos theta. Okay. So here we have to write something. So that is electric field due to electric field at equatorial point due to dipole. Okay. So that means here what we have to write? Consider an electric dipole, that is minus q and the plus q, or separated by distance 2a, which are separated by distance 2a, and dipole moment what? P is equals to 2q into a. Okay. And here we have to find the electric field intensity at point P where positive test charge placed. Okay. So the distance from center to point P is what? Point P is R. That is OP is equals to R. Okay. Now here we are getting some electric fields, no? So that is electric field due to positive charge at P is what? That is electric field due to positive charge is what? 1 by 4 pi epsilon naught, that is q by r square plus a square. Okay. And electric field due to negative charge at point P is what? Electric field due to negative charge is what? 1 by 4 pi epsilon naught q by r square plus a square only. Okay. So here in the dipole case, see here, so as this is a dipole, minus q and the plus q, separated distance 2a. So here we want the electric field at this point, the electric field direction due to positive charge. This is the positive charge. So here we are getting E field due to positive charge, and here this is the E field due to negative charge. Okay. Now here these opposite components are cancelled each other. This is the E field due to sin theta components are cancelled. So these two are cancelled, and here we are getting the resultant electric field. So that is E plus Q plus E minus Q. Okay. So that is equals to 2E. Okay. So this is the E resultant. Okay, now here we want to get the E resultant. So that is E resultant value is equals to 2 magnitude of E cos theta. Sorry, here we have to write the cos theta. Okay, now E resultant is equals to what? 2. The magnitude of E is what? Here the magnitude of plus q must be is equals to the magnitude of minus q, that must be is equals to magnitude of E. Okay, so that is 2 into 1 by 4 pi epsilon naught. Magnitude of E is what? Q by r square plus a square. This is the magnitude of E. But here we have to get the cos theta. Okay, so for the cos theta, see here. Here center. So this is the angle theta. So as this is the angle theta, it is the equatorial triangle. So here we have to get the triangle angle theta. So as here is the theta, so alternate angle corresponding angle is theta. So here is the theta, then alternate angle also theta. Okay, so as here is the theta, here also theta. Okay, so see here we have to get the cos theta now. So cos theta means this is the theta. Okay, so here this one is what? R square plus a square. This one is what? R square plus a square. Okay, so this is r square plus a square, this is r square plus a square. Okay, so here as it is a theta, so the distance between here to here is what? A. Okay, so this is the hypotenuse and this is the adjacent. So cos theta is equals to what? Adjacent by hypotenuse, that is r square plus a square. Okay, so here a by under root r square plus a square. Okay, so now E resultant is equals to what? 2 into QA, that is by 4 pi epsilon naught into r square plus a square, r square plus a square. So that is r square plus a square. This is whole power 1 by 2, no? Whole power 1 by 2 plus 1. So that is 3 by 2. Okay, so already we know that P is equals to what? 2Q into A. Okay, so P is equals to 2Q into A. So that is E resultant is equals to what? P by 4 pi epsilon naught r square plus a square whole power 3 by 2. Okay, now see here, when we are compares to the distance between those 2 points, the point P distance is very much greater. Okay, if you are taking the point here, r is greater. If we are taking the point here, so that means we are taking the point, so that is r is very much, when compares to the a, r is very much greater than the a. So that is r square plus a square must be is equals to the r square. Okay, so that's why it can be written as, so electric field resultant is equals to 1 by 4 pi epsilon naught P by what? R square plus a square whole power 3 by 2, when r is greater than, very much greater than a. So r square plus a square must be is equals to r square. So that is E resultant is equals to 1 by 4 pi epsilon naught P by r square whole power 3 by 2. So 2 will be cancelled, then E resultant is equals to 1 by 4 pi epsilon naught, so P by r cube. Okay, so see here, this is the electric field which is due to dipole at equatorial point. So that is equals to P by 4 pi epsilon naught r cube. So this is the magnitude only. This is the magnitude. Okay, but here we have to get the direction. Okay, so for the direction, already here this is the minus q and this is the plus q. So here this is the resultant electric field direction, E resultant. So this is the E resultant direction. Okay, now dipole moment direction is from always from negative to positive. So this is the dipole moment direction. This is the resultant electric field direction. So that means the direction of electric field, so that is at the equatorial point, is always always opposite direction to the dipole moment. So that is P. Okay, so dipole moment is direction is from here to here and electric field direction is from here to here. So when we are taking any point on the equatorial, at any point the direction will be opposite to the dipole moment. The direction of the electric field is always opposite to the dipole moment. Okay, when we are taking any point on the equilateral, when we are taking here, okay, so when we are taking the point here, okay, so here also this is a positive charge, then the electric field is away from the positive charge, so this is the electric field direction. So this is the negative charge, then the electric field is attracted towards the negative charge, then the resultant electric field is in this direction. This is the E resultant. So at any point on the equatorial line, so the electric field direction is always opposite to the dipole moment. In the axial case also, when we are taking the electric field here, then also the electric field direction is in the direction of the dipole moment only. Okay, so in the axial case we are taking along the direction of the dipole moment. In the equatorial case we are taking the opposite to the dipole moment. So now here E equatorial is equals to 1 by 4 pi epsilon naught P by R cube. Okay, E axial is equals to what? E axial is equals to 1 by 4 pi epsilon naught P by 2p by r cube. So see here, by comparing those two ones, here E equatorial is equals to, so here see here 2 times of the equatorial is equals to E axial. Ante kada? So here axial is multiplied with the 2. Okay, so here 2 times, here we are getting the effect 2 times, here we are getting the effect 4 times. Okay, so that means the effect which is due to dipole at the axial lines is greater than the at the equatorial line. Okay, so here we are getting the effect which is due to dipole is 1%, here we are getting the effect which is due to dipole is 2%. Okay, so that is 2 times of the equatorial must be is equals to the electric field which is due to the axial point. So this is electric field at the axial point and electric field at the equatorial point. Okay, now here when we are placing the electric dipole in the uniform external electric field, then we are getting some more results. So that is the resultant, the net force will become 0, but there exists some torque. Okay,